Start the recording. All right, I started the recording. S- those who are not in class yet, just to give you a heads up, if you are watching the video, be on time from next class. Otherwise, if I'm gonna lose few minutes at the beginning, at the end, I gotta be rushing. So I don't wanna rush. Uh, One student had excused absence from the exam. I was expecting that student was gonna show up yesterday as promised, but didn't show up. So if you're watching, listening, I'd expect you take care of that as well. Now let's move to our main topic. So we had exam in last class, which has actually technically two parts. One is the exam two questions in class, and the other one is most likely question number one. Except one student I gave exception, which is question number two, right? Yeah, and these thing I want it now. So if you are done with that, I want this submission now. If you miss the class, then you can. I think I have a Dropbox, but I can't open the Dropbox because of that excused absence for one student. So you can possibly email it today. Okay, so that's in record. So that's about the exam. Now the new topic is module 4. I started with the theory in last class. I think it's better if I gonna turn on the light there. So let's see. Do that. All right. You should be seeing it better now. So my I started with module 4. So my thing would be like the agenda for today's class would be start with let me start writing here. So start with agenda. So review past class, which is module 4, right? Because it happens like a week ago. We had an exam in last class, so might have forgot. All right. So then I have one math, so one exercise. So one exercise, and I have this homework 4. I would say that you might have seen I uploaded homework 4 hints. How many of you started with homework 4? Possibly none, because I haven't started any math problem yet, right? So it's all right. So let's do a quick overview of what happened in last class. 1 week ago, you started learning this, okay? So just to give you a heads up here, we started this 1D steady state no heat generation. I want everybody to start taking the class notes. If you're doing whatever, I don't know, I mean, just start taking the class note. That's the only way of learning. Okay, 1D steady state q dot equal to 0. If you had that situation, can you write the heat equation and come up with this? How many of you can come up with this? Everybody's confident come up with this equation? Okay, once you have that equation, then you can solve to find the temperature distribution, which was part of the exam 1, right? You remember the temperature distribution equation? Okay, so temperature distribution equation, you can find it. And not only that, you can find the Q, which we would be using here as the same equation we learned it in chapter 1, right? So it will be T2 minus T1 divided by L. And here's the thing, if there is no heat generation, okay, and the 1D assumptions and everything is there, then this heat equation or heat rate equation becomes this simplified form, okay? So in last class, this was our starting point. Then we slowly started understanding the thermal resistance. Everybody remember the thermal resistance? So we did talk about two different kind of thermal resistance, okay? Now I want you to write those two equations, see if you remember. I would like to see that if you remember them. So you have this R conduction and R convection. I wrote both equation in last class. And in case if you are wondering, I want everybody to write it. Okay, this could be a quiz. Okay, so if you have, say, like a stack of plain wall, right? Just stacked one after another, right? You see, you have these two layers here. Say, like this is layer number 1, this is layer number 2, and you have a ER layer here, you have a ER layer here, right? So then, how many resistance is there, Harley? How many resistance there? You have two solids, 4, right? So these 2 convection, 2 conduction, those are the resistance. Now you can say them R2, R1, R3, R4. Now if I'm going to say in this side, this is the temperature, right? T infinity 4. And if I'm going to say this side, T infinity 3 is the temperature and H3 is the convection coefficient, right? So then you would like to write, so this could be a review and at the same time today's class agenda as well, because if you are done with writing those equations that I'm giving it to you now, then you can easily deal the math problem, okay, the math problem that I have. If you are good, you have the class notes. You're missing something? What? You can? Anybody can borrow anybody can lend a pen to Defu. I don't have pen here. I do have bunch in my office. Thank you. Thank you, Logan. Alright, so what I want from everyone is write those 2 equations. First, write the generalized equation, okay? And then write the equation for R1, R2, R3, R4. You'll need some more info, okay? So you'll need, say, like for this layer, K2 and K1. What is K, Isaac? Thermal conductivity, right? So you have these 2 layers, 2 different thermal conductivity. That's so obvious, right? Understand? You need a few more temperatures as well. You can name this thing. Okay, this is T2. This is like T2S. This is T21, and this is T1S. Or this S, you can simply take it out. This is a little congested. My intention was to do a quick quiz, okay? So what I want from all of you, write these 6 equations, okay? So you have this R for conduction, R for convection. First, try to remember those. Anybody remember? We need a few more things. I'm sorry. You need the thickness for these 2 sides of the wall. So the thickness, so like this thickness is L1. So like this thickness is L2. I'm sorry, this looks a little congested, but I tried not to do any overriding, okay? So what I want from all of you, write this R equation. First 2 are 1, I say. Those are generalized, right? Remember? So write those generalized. If you can remember those generalized one, then you should be able to write the other 4, right? R1, R2, R3. Then if you can able to write those 6 equations by yourself, the math that we'll be doing now, you can do it by yourself. Okay? That is it. Obviously, I'm going to give you some hints and some direction initially. How those resistors are arranged? Are those in series or parallel or a combination? Anybody? How those resistors are arranged? You're seeing those are in series, right? You're seeing the circuit, all of them are next to each other, right? Those are in series. So in electrical class, what did you learn? If the resistors are in series, the total resistance would be simply add them, right? See, the beauty of this thing is that when you are able to write this R1, R2, R3, R4, you can able to find the total R, right? And that would be needed as well in the math problem, both in homework and today's class. Okay? So our focus today, main agenda, is actually doing the math. Okay? But before we even jump into that, we gotta know how to write this. Do you done with that? See? Check. No, not yet. Are you done? And in your book, sorry, in the Bright Space, I uploaded the appendix today. Okay, in case you need that. Let me have a look. You guys remember L over Ka? That's the conduction. L is the thickness, K is the conductivity, A is the area. Everybody remember that? Okay, that's for conduction. What about convection? 1 over HA. Remember, H is the convection coefficient, A is the area. Okay, so I'm just exposing the first two. Let me write them. Okay, so this L over Ka, and these are the generalized equation, right, Isaac? 1 over HA. So these are, I'd like to see generalized equation. Where A is the area. What area? Which area? Is this area? Let me try to do the highlight. Is this area? Do you see the color code? This makes sense? But L is here. L is here, the thickness. What thickness? Again, what thickness that we are talking? Let me do a color code. This is the thickness, right? Everyone understand? So then you should be able to write R1, R2, R3, R4. Don't forget to put on the circuit the temperatures. You know the temperatures, right? So T infinity, you're done, Logan? You put the temperatures on the circuit? Yeah, the usual way you like to write, you like to connect it just like a circuit in electrical that you learn, right? This should be T infinity, this should be T infinity 3, and then intermediate temperature, this is like T2, T12, T3. Understand? That's how you write. So this is the quiz everyone is doing. Mac?
David will be in a minute.
Yeah, I understand. So I did record this. Like I hardly doubt you have time to catch up because you spent like more than 10 minutes already on this topic. Okay. Now we're gonna start with the math, but don't worry, I'm gonna help you in person. Right. Okay. So you got it? Yeah. So this area, what do you think the area is safe? It's not changing. Very good. Okay. Can you draw the circuit with all four resistors? You did it? Can you draw the circuit with all the resistors and all the temperatures? So if you are done with writing them, I see like I checked three of you are done with perfect result. Now I give you directions for everyone. Just draw the circuits, the whole circuits with all the resistors and all the temperatures, okay? So make sure you put the temperatures on the circuit. So once you are able to do that, how to put the temperatures in the circuit, then you can do the math like piece of cake, okay? I'm giving a little bit time for other three. Seems like you guys are still working. Raise your hand whenever you're done. Okay. Whenever you're done. So I want what? Like these two things I already wrote, right? The other four you will need to write, right? R1, 2, R4. And then I wanted to finish this circuit that I had it over there with 4 resistance by putting the temperatures on the circuit. So I'd like to see these 4, 5 things that you have done. So then I can check. Whatever is not there, I'd like to check that. Okay? Means the temperatures of the circuit so that you know where the temperatures are located. By the way, you guys remember temperatures are equivalent to voltage. You guys remember that? Okay, Q is equivalent to what? Q is I. Q is equivalent to I. I think you remember that? Q is equivalent to I, like the current, right? So these temperatures must be put on the circuit. If you know how to put the temperatures on the circuit, then the math that I'll be doing, you can do it by yourself. Okay, that much easy. Okay? good time. Make sure you understand the thermal circuit. That is so important. Let's see. Oh, perfect. I say like you wanna put a subscript as a T54, T50. That's how I put it, but it's fine. If you wanna put it T52 1 and 2, it's fine as well. Okay? It depends on your sketch. How you put in your sketch. Okay. Everybody will take some time to catch up. You are in the capstone, right?
Yeah, we were meeting with the HVAC class.
Yeah. So tell the next time, like, if you miss the class, then it's hard to catch up. It's alright, I'm gonna work with you in person, okay? Whatever you miss. What we're doing here is see this fill in the blank. So R1, R2, R3, R4. Based on those generalized equations that I had, which you might remember from last class, they were writing it for this scenario that I had portrayed on the right side of the scan. So two layers, and we have this air layer 4 and 3, right? So air layer obviously has a infinity temperatures, as a subscript infinity 4 and infinity 3, and H4 and H4, H3 are the convection coefficients, right? So you would like to put the temperature on the circuits. That's one job. Like you see, I draw a circuit at the bottom, all are in series, right? We'd like to put the temperatures, all four temperatures, like T2, T1, T3, so T1, T3, so everything here on the circuit, and we'd like to write what is R1, what is R2, what is R3, and R4. So that's the job. Okay. Okay. How my okay.
You might need to get started.
Okay. So let's start with this one. So this one is the conduction. These are in your case R2 would be the conduction, right? R2 and R3. No. R1 and R2. Sorry. R1 and R2 is inside, right? Are those conduction? So the way I named it is like this one is R1 and R2. This one is R2 and R3. Yeah. You may want to change this. So that is on your liberty when you solve the problem. But now this is the way I wrote, so maybe you can follow it. Okay.
That was the first one.
You understand, Harry? You're following what I'm saying? Okay. So just take a look here, Harry. So that way I can give you the pitch for
Oh, yes.
right? See there are the four resistance. Obviously, we're seeing R1 and 2 are the solids, right? There are three that we draw. And 3 and 4 are for the what? For the convection, right? For the years, right? So you see, the generalized equation for conduction is Albert equation. Okay, and the generalized equation for conduction is 1 over H. So this is 1. Okay, so here's the thing. This is 1. Oh, yeah, 1 over H. Okay, yeah. Alright. So why this is no L here for conduction? Obviously, conduction happen all of the places here. Here is the thickness, right? L is for thickness. So now here this L1 and L2 for these two different layers, right? Understand that? So that is that. So now, if you are trying to write R1 and R2 specific to these two resistors for solids, then you'd like to write L1 over K1A here, right? And for the second one is R2, L2 over K2A, because L and K those are changing, right? Only the A is not. You understand? Alright, so that's the conduction. What about the convection? The convections are 1 over HA, right? So A is not changing, H is changing. So the left side for this one, it is, take a look here, I have H4. So you're going to say 1 over H4A, and this one, you have to say this H3, right? 1 over H3A. So these are these four resistors, right? Now, the final thing I want from you, Harry, so here you draw the circuits, right? So in the circuits, this R is the resistance equivalent to the resistance of the equivalent resistance, right? There is an I of current that usually passes through all the resistors. You remember that? And that the I is the same. The same thing is the Q. The Q is same for all the resistance, right? So now this Q will come find it later, but here you need to put the temperatures which are equivalent to voltage. You remember in the electrical circuits you have the voltage here to here. So these temperatures are the voltage, right? So you have this T infinity 4 here, right? T infinity 3 here, and in between you have some more temperatures as well. Like you have the surface temperature of the left side of the wall, you have the intermediate temperature like where the sandwich happened, T1, 2, and you have the right side of the wall, the steel temperature. So these three temperatures needs to be put here as well. So basically what I'm saying, like, once you draw the circuit and able to put all the temperatures here, okay, that's why it's so important to understand. So finish it. I want to see everybody finish it. Okay. If you are you doing. So you write the total resistance. Now you wrote here like 3 resistance, right? I'm seeing 2 convection and 1 conduction. Now you have to understand there are 2 layers of conduction, right? Because take a look here at the sketch. The 2 solid layers are stuck. Yeah? You don't see? Why don't you come? Are you mentioning? You wanna if you have issue seeing that you can receive it, it's fine. Or you can receive it. Look in mind. Okay, you can receive here, okay? That could be perfect for you. Look, next class on. If it bothers you, you don't need to think it here. There's a here. Alright, so you're going in the right direction, okay? All the thing you gotta do is like, I mean, those who are done, like, obviously Steve Logan and I know, I did check Isaac's work. I mean, you guys do whatever, like, chill, but others, I'm trying to address everyone is on that topic. If they don't understand, then they will be making some issues. So, what you want to do here, Isaac, is you'd like to put all the circuits on the right? So, how many circuits you have? Like 4, right? So, okay. So, then, the very important thing is to put those temperatures on the circuit in proper places. Like on the left side, what is the temperature? T4. The right side, you have this temperature, right? And in between, you have these 2 solid there, okay? So this is like a solid, like R1 and R2, right? This is R4, this is R3. These 2 are convection, right? So you did right there. So this is, you did right there. Because you did put it this way.
My notes, I
For
might
your
homework
case,
stuff
it
is
would
mine,
be
but outside of
so
homework,
this is 51. How many layers do you have?
like my class notes are just
No, you have like 2 solid layers. So 1,
yeah, like progressive
2, right?
notes of yours.
Understand?
Like
And then, so this is your 1, this is your 2, right? And this is the T4, or T4, whatever you want to say, comma H4, right? What is that? The year, right? T infinity 3,
My stats notes are not well enough.
then H3, right? So you have this solid resistance, this is L1 and L2, and this is K1, this is K2, right? And then this solid resistance goes here. It should be L1 over K1, K1, A, right? This will be L2 over K2, A. And this R4 is the resistance for the year, which is 1 over H4A. And this R3, which will be resistance for this year, it will be 1 over H3. You understand now? That's what, so why don't you redraw what I just did? Okay?
That wait, you're talking about Q and then
Okay, so what you want to do here, this is your homework. This is your.
I haven't started this.
Okay, get the paper. Let me get it started. Okay, here. So otherwise it will take forever. So you see here you have these 2 layers, right? So L1 and L2, those are the thickness, and obviously it has the same area. The sketch doesn't look that great. Understand?
Yeah.
All right. So then these K1 and K2 here are conductivities for these 2 layers, right? And you can assume those 3 different temperatures. Say like this is T. I say this is 1 and 2. Say like this is T1, this is T1, 2, and this is T2. And say like I have air here and here, right? To fluid. So say like this is T infinity 4, H4. And this name are up to you, whatever you want to say. It doesn't really matter, right? So it's 3. The convention, the name. So because I have 1 and 2, so I have 3 and 4 here, right? For the year, I have 3 and name. This is yeah. So now those circuits, like how many resistance here? For 2 convection and 2 conduction, 4 resistance, right? So this is R2, this is R1, this is R2, this is R3. And what is the temperature here? T infinity 4. What is the temperature here? T infinity 3. What is the temperature here? T1. What is the temperature here?
T1, 2.
What is the temperature here? T2. Now this is done. Now what is R1? What is R4? What is R2? What is R3? Now I'm going to do 1 conduction and 1
convection. So R1 would be L1 equals K. R4 would be 1 over H4, right? You finish the other two?
Yeah. That, but since I missed,
Okay.
they said online.
You guys both understand?
Yeah.
You guys can do the math by yourself now?
Yeah.
Confident? Perfect. Alright. Let's go here.
Which one's
David,
the
somehow? Sorry, hands up.
The one
Next.
that's right, yeah.
So, and this convention, like, the way you do it depends on how you are putting the sketch. So, the way I put it on the sketch, I would say, like, if you guys equal to solve on two, then for the areas of convection, you like to choose something different. That you can separate them.
Oh, you're saying,
The substitute.
K1, K2, H3, H4.
Exactly. Similar. And I would say, don't forget to put the sketch all the time. It's so important because that is going to tie up your equation. So this is, let's say, 1, 2, right? And then I would say you want to put the capital here. So say like this is T1, T1, 2, this is T2, right? And say like you have a yard layer here, you have a yard layer here. Okay? And you can assume this is like, that's the way I put, doesn't necessarily you want to put the same way. This is H4 because this 1 and 2, 3 and 4 I'm doing this way. And this is like, T infinity 3, and then this is H3, right? In this case, maybe you have to update it like 4 and 3. It's fine, but the important thing is putting the resistance. Okay, so this core resistance that you have, where R1, R2, okay, I put R1, R2, R3, and 4. So R3 will be this 3 and this 4, and this one will be R4, this one will be 3, right? Now it doesn't really matter which order it is, as long as it ties with the step. Okay, and then you'd like to start to put the temperature. That is so important because these temperatures are equivalent to what? The voltage, and this Q is equivalent to what? I current, right? And you'd like to be able to put all the temperatures in between. So this one is like T1, this one is like T12, and this one is like T2. You understand? So once you have the circuit drawn and understood it properly, then you should be able to write this Q equation where you can write this del T, okay, divided by R. Now the same Q is for here, 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 or here, or for the total. So say like only these two temperatures, then you find the R total and you add the all resistance, right? And you want this to understand? Alright. I have kind of personally addressed everybody's thing except before you are done. So you have this for resistance, perfect, and you start to put the temperatures. Why you have this surrounding here? Yeah, T1. This one should be T1 as per my case, right? This one should be T1, 2. This one should be T2, right? And this one should be T infinity 3, right? Now surrounding is not important here, though. And then you'd like to put this here. This one is not a convection. This one is either convection. And these two are convection. Should be yellow. Okay. This one is conduction again, right? Two solid layer, see? In between, right? And over. Understand now? Sure? Confident? Is the math? What is the total resistance? I want now, everybody, I want you to write two things now. Everybody done with that? I address personally everybody. So I want you to write, let's do this here. I want you to write the R total. R total equation. R total will be what? All of them are in series. So just simply add them up, right? I'd like to write the R total. Once you write the R total, then I'd like you to write this I equation. Remember I R, V equal to I R. Do you remember that equation? That's for the electrical circuit. V equal to I R, Ohm's law. So you want to write the similar thing. Instead of V, you would like to write del T, or potential difference, right? Del T equal, instead of I, you would like to write Q, right? Q. I is Q, remember. So again, V equal to I R, you remember that, right? V is the voltage, I is the current, R is the electrical resistance, right? So instead of V, you want to write del T. That's the equivalent thing, right? comma, analogous. And instead of I, you want to write Q, right? Current is equivalent to heat rate, Q, okay? And instead of R, you already have the R, right? This R. So I would like you to write those two equations, everyone. I would like you to write those two equations, okay? Once you're done writing them, then you are actually ready for the math that I have it planned. And then I can discuss more with the homework hints, homework number 4 that I uploaded already, okay? I'm gonna give you some of the hints so you can finish the homework by next class, okay? You understand?
Yeah, I heard it.
You have a few questions already.
Perfect. Yeah, perfect. So this del T and this R. Now here's the point. I say, tell me something. This del T and Q R. What are you talking about? You have so many R's. What del T you are talking? You have so many del T's. That could be an interesting question, right? Think about. Think about it. So see that once you write those things, what I said, right? The Q equation and the you write the Q equation, the Q equivalent. Well, that's the first thing I said. Like E equal to IR, write that one first, and then write. Like remember, E equal to IR, you learned from your class, right? So once you write that V is actually equivalent to del T, which I know I wrote it, but that's for generalized case, not for this specific case. Now that I have this 4 resistance, right? Which you want to put the temperatures here. So this is T infinity 4, this is T infinity 3, right? You understand? We're going to put the temperatures here. T infinity 4, T infinity 3. So now you see here, both of you need to listen what I'm saying. See, V is del T. What is your del T for the total circuit? T infinity 4 minus T infinity 3, right? Isn't it? Alright. So I is Q, is the same Q going on all the circuits, right? Okay. And then what is the R for the whole circuit? Just this R total you wrote, right? For the whole circuit. You understand? Okay. Del T is this what we wrote. Instead of V, that is del T, right? Instead of I, that is a Q, right? The heat rate that is going through that. And instead of R, this is the R. Understand? So can you write that equation? Finally, write that equation again with the total circuit. Okay? Both of you wrote this equation. So instead of so for your case, okay, perfect. So Q, and you would like to write obviously small q, right? So the capital Q usually they use it for heat. The small q is for heat rate. Okay, that's the convention. Okay. So, okay. Yeah, I'm saying like there's a good progress on everyone. I mean, I'm kind of confident that you guys can deal with that. Now, let me start putting things all together, okay? And then we're going to do the math. And on the math, I'm going to give you some hints and hopefully you should be able to finish it by yourself, okay? Anybody seeing where I left my stylus pen?
I was right here.
Alright, so what I was saying, let me just first put everything what I was saying. So I was saying here, just put all the temperatures, so which I'll be doing here. So this is my T infinity 4, this is my T infinity 3, this is my T2, in this case it is T2, this is my T21, this is my T1, right? And I was saying, see, this Q is flowing through all the circuits. And then I individually addressed, everyone got it now, L1 K1A, this one L2 K2A, this one 1 over H3A, this one 1 over H4A. Everyone understand that, right? All right. So then I said, okay, do one thing, find the equivalent R. So which is R total equal summation of R, means all the R. I did address all of it with everyone. So you have this R1 plus R2 plus R3 plus R4. Now you can write the same thing again, which is 1 over L1 K1A, L2 K2A plus 1 over H3A plus 1 over H4A, right? How many of you haven't done it yet? Everybody done it yet, right? Already, right? Up to this point?
All right. So if you are in that situation, then you can able to write the Q equation. Again, Q equal del T over R total. Now this del T is what del T? This del T is this T infinity, this T infinity 4 minus T infinity 3. Now you may say, why don't you put T infinity 3 minus T infinity 4? Can anybody answer that? I'm putting T infinity 4 minus T infinity 3. But you may argue, which you could have valid reason. Why don't you write T infinity 3 minus T infinity 4? For the obvious reason, T infinity 4 is bigger than T infinity 3. So my Q is positive, right? And the Q is showing that direction. You understand? Highly, does heat ever flow from low temperature to a high temperature? It does. It doesn't. Highly give you a correct answer. But it will in a refrigerator or in a AC, but you need to force it through compressor and other cycle. We learned it in thermal class, right? Remember? But heat always flow from high to low temperature, right? So Q direction, if it is T infinity 4 minus T infinity 3, that means we have a positive value on the right side, right? So T should be positive. You understand? Now, if you're gonna put like T infinity 3 minus T infinity 4, you're allowed to do that. In that case, the Q convection, the direction that you're putting in the sketch is wrong. You just have to say, okay, negative value, actually Q is actually following from the other side. Does it make sense? Are you understand what I'm saying? All right. If everybody understand this, then obviously, I mean, that's pretty much it from me. But I'd like to do an analogous electrical circuit as well. So if you remember, you have this V over R equal to I. Okay. So if you want me to do a little bit more, so this I is equivalent to this Q, right? This R is equivalent to R. That's obvious, right? And then this V is equivalent to del T. Okay. Now, if I'm going to say, okay, I remember this T infinity 3 and T infinity 4. If you know them, then you can find the Q, right? You agree? All right, Harry. Now, if I'm going to say you don't know T infinity 3 and T infinity 4, you only know Q1 and T2. Can you able to find the value of the Q? How many resistors there? 4, right? All I'm series. So the same Q is flowing through all of them. So if I'm going to ask, you see, Matt, what I'm saying?
You can find it for 2 and 4 as well, or for
1 and 2 as well, right? Why is saying that? Because it doesn't matter if I'm going to pick like one single resistance or 2 resistors or all the resistance. Okay, all it matters when I'm considering one resistance, then I must consider the end temperature for those 2 resistors. For that particular resistance. When I'm considering 2 resistors, I'm considering the end temperature for those 2 resistors. When I'm considering 3 resistors, I'm considering the end temperature of these 3 resistors. When I'm considering all 4 resistors, I'm considering the end temperature for those 4 resistors. And the Q is always same. Okay? So how do you think about it? I have a wire going from here to this office, right? So it's a single wire. If current is flowing from this point to this office through this wire, is this a one current or different current? It should be single one current. It's not changing, right? You don't understand? The current value doesn't change. Now, from here to this office, there are multiple layers of resistance. That may reduce the I value. That may reduce the I value lower, right? You understand? That may reduce the I value, but the I is still the same from here to this office, as long as it's the same way. The same concept is, as long as you have all the resistors are in series, it's the same Q. Everyone understand this? You got it? Make you got it?
So if you understand everything, now I'm gonna give you a problem, and I bet you can finish it by yourself. Okay, I'll obviously help you. Get it going. Means like you start drawing the sketch and everything. Okay. Did I left my phone somewhere? So this is the math problem I have. Did I left my phone anywhere? No. Good. I actually don't need the phone. My phone has the class note, but it's all right. I can deal with that without class notes. So a house has composite walls, okay, of plywood. The composite walls of plywood, fiberglass insulation, plasterboard, as indicated in the sketch. How many layers there, Defo? 3, right? Because the plywood, you have the plywood, fiberglass insulation, you have the plasterboard, right? Now I have it in here in the sketch. This was meant to show you the practical application, okay? Everybody, please start to take the class note because I'm gonna start dealing with stuff. So how many layers do you have again? 3 layers. Everybody got it? So I have these 3 layers. You'd like to draw the sketch. Everybody like to draw the sketch, okay? If you're gonna start late, then you're gonna end late. That means you're gonna falling behind when I'm giving the lecture, okay? You don't want to be on that situation. So you have these 3 layers of solid, right? So on these 3 layers of solid, you have these 3 different thickness. You can assume those are L1, L2, L3. Okay, so you have this 1, 2, and 3. Those 3 different thickness. All right. So then it says here, indicated in this, on the cold winter day, the convection heat transfer coefficient HO, say like this is the outside layer. HO, and this is the inside layer, HI. So they gave you those 2 values, HO and HI. The total wall surface area, they gave you the surface area value as well. So A, 350 meters square. Indoor outdoor temperatures they also give you. So like outdoor temperature is TO, and you'd like to draw a cloud sign. Indoor temperature TI, you would like to draw a cloud sign, right? Everyone's with me so far? All right. So then what else? Determine the symbolic expression of total thermal resistance of the wall, including the inside and outside convection effect prescribed the condition. Okay, so you have how many resistance here? Anyone? 5 resistance. 3 for solids, 2 for those fluid, right? The air layer inside and outside. Okay, so you are given with these 3 different temperatures. So now why don't you start drawing the circuits? You have you said like 5 resistance, right? Okay, and what are the outer temperature? You have TO and you have TI here, right? Everybody understand this? I haven't done anything so different what I've done before, except I have this time how many resistance in the solid? 3 instead of 2, right? And I have those 2 outside temperature, like indoor and outdoor, 2 air temperature, indoor and outdoor, TI and TO. Those I put it over there, and I can possibly put, okay, this is my RO. I can name it this way, right? RI, and this is my R1, this is my R2, this is my R3. Can I do that? Those 3 resistance. Okay, now question is what that we know here, okay, and what is that we gotta find? Let's deal with the engineering format. Okay, so let me start the givens here. So what are the givens? Anyone? HOHI, you would like to start with that. So you have convection coefficient. I'm doing the shortcut, right? For indoor and outdoor, which is HO and HI. What are those values again? 60 and 30, right? Watt per meter square Kelvin, 30 watt per meter square Kelvin.
Okay, and then they gave you the total area, right? Surface area of the wall. A is 350 meter square. Okay, they give you the temperatures, right? So you see me anytime writing the shortcut of temperature TEMP, that means that's the temperature, right? COE double F dot means coefficient. CONV dot means convection. COND dot means conduction. Okay. From this point on, you'll be seeing it all the time. So you have these two temperatures given. So TO and TI, indoor and outdoor temperature. One is given as like what? Like okay. So indoor is 20 degrees Celsius. Outdoor is it's a cold winter day, minus 15 degrees Celsius, right? It's very chilly out there. So what is that they are asking you to find? They also give you some thickness. So they gave you the thickness, as you can see, the fiberglass thickness so is 3.5. Everyone can see it from the sketch. Okay, so they have this plywood and plaster board. So plaster board is the gypsum board here, right? That is 5/8, and then the plywood. Zoom the plywood. Anybody did construction work before? A little bit. What is the usual thickness of plywood? Like you put it here, like this plywood, right? Thickness. You never noticed? Usually the standard is 0.5. I mean, and again depends, like residential, right? In commercial, it could be a little bigger. Did you ever work with construction? No.
Never for a construction company.
You remember the plywood thickness?
Well, I would, yeah, about half an inch.
Even half an inch. But can you get really half an inch? Or it's like
Usually a little
a
bit less.
little bit less, right?
Four.
And that's for the residential, right? For commercial, it's a little thicker, right? They usually does commercial also use 0.5?
It goes from like 3/8 to 3/4.
3/4. Okay. All right. So let's assume a plywood thickness. What do you want to do? 0.5, right? So let's do plywood thickness as 0.5. All right. So now you have those three thickness and the insulation. They don't have an insulation thickness directly. Okay, actually they do 3.5 inch. Okay, so let me put those thickness for those three things. So like plywood first, I would say plywood. Plywood for indoor. Now tell me something. Is the plywood is the L3 or L1? Fiberglass is obviously L2. You understand, right? The insulation. The plywood usually we put it inside, right? So that should be related to TI, indoor temperature. That should be L3, right? Therefore, so this is the plywood, right? Understand? Everybody understand, right? Isaac, you got it? So it's L3. So let's put this L3, plywood L3 thickness. Okay, L3. What is the value of L3? We said is 0.5 inch. So can we use 0.5 inch here? It's a SI system problem, right? So we got to convert it to what? Meter. Can anybody give me the value? I left my class notes. I don't have it. Either I have to do the math by myself, or you guys have to help me. So what is the value here? 0.5 converting to 0.5 inch converting to meter. Give me the value. You work on the background. Okay, and you have some more. So fiberglass. So fiberglass, you can say this is L2, which is 3.5 inch. So I need this in meter. And then finally is the board, plaster board. So the plaster board is L1, which is 5/8. Okay, I need these three values, and those are the givens. Whenever you have some values, you know that unit conversion, how to convert 1 centimeter equal to 2.54 inch, right? I mean, you can Google it and simplify inch to meter conversion. You don't have to go with the centimeter. No, meter, go with the meter.
0.0127
That's the plywood?
meters.
That's the plywood?
Yeah.
Okay, fiberglass? 0.0?
889.
The plasterboard?
0.0159.
Thank you. And what you're trying to find, two things. The first is total thermal resistance. I need both the equation, means R total, which is, by the way, all of them are in series. Just have to do the summation of R. And then you got to find the heat rate, Q. Okay? The first thing is actually technically done, right? So this R total is equal, I'd like to write them here, R1, R2, R3, RO, and RI. Now, these are the form resistance. Now, if I've seen over the years, like students forgot to put the description of those R. Like you gotta put like what is R1, R2, and R3. This is like L1 over K1A, L2 over K2A. You know what I'm saying? So you wanna write it in a descriptive manner. So this is the first job you wanna do, and the second job is you wanna find the value of the Q. So you know those two temperatures. You should be able to find it by yourself. Everybody. So I want you to solve these two problems, part A and part B, by yourself. Okay, obviously I'm gonna do it after 5 minutes. Okay, let's see what you can do within 5 minutes. Okay, this shouldn't be a bad problem at all. I mean, within 5 minutes, if you can solve it by 10 minutes, definitely you should be able to solve it. Okay, right, Isaac? You can solve it, right? Yeah. Maximum 10 minutes that you need to solve this problem. So part A is almost done. All you gotta do, write another line over there, just explaining what is R1, R2, R3, R4, R3, R0, and Ri. And part B, where actually, once you have the value of the R total, then you can just simplify the value of the Q by using this del T over R equation. R you already defined in part A. So del T you already know, right? Those two temperatures given, right? Minus 15 and 20. So then you can easily find the value of the Q. We've just done this thing in the theory part, remember? And try to finish it ASAP. So I can pull up the homework and then I can start talking a little bit more about the homework. So you can start doing the homework by yourself, okay? You got the value already? Oh, you need the K values. Thank you. So on that aspect, you definitely need the K value. On that aspect, I'd like to show you something. I had the appendix. Everybody, so you have the appendix here. Let me show you how to find the value of the K. So if you're gonna go Brightspace, everybody have the access of Brightspace now? If you're gonna go Brightspace, you'll be seeing me uploaded this appendix. Everybody see the appendix? How do you see the appendix? So go Brightspace, you'll be seeing the appendix. And then there are two different books appendix there. You can pick either one. Sangel is usually the easier one. You pick the Sangel, you download it, okay? You download this appendix, and then you open this appendix, okay? Once you open this appendix, so what materials you are actually working here? The building materials, right? I would say you wanna go table A5. Harley, Mitch, you see that? Table A5. I would say you wanna go table A5 because of the building materials. I hope that's what it is. Okay, A5. Because my notes does have all the values. I don't have the notes with me. A5. Did you find everything? So plywood. I'm seeing the plywood here, right? So what was the thickness, Mitch, for plywood you found?
For plywood, or in meters,
Uh-huh.
it was 0.00127.
1.0127. Means 10 centimeters. Oh, 0.00, right? 2 zeros?
Oh, wait,
Point
it's not
zero one
meters
zero.
or millimeter?
Oh, in meter. 10, right?
Yeah,
Is it 10 or 2 zeros? After the point.
1 0.
1 0. So 10 means is it like equivalent to 10 millimeter? It should be. Like 127. We don't have 127. You want to do like the interpolation.
12.7 millimeters.
Huh?
12.7 millimeters.
12.7 millimeter. So, oh, then you want to go 13 millimeter. So, what is the K value here, Matt?
I can't read which column is in values.
This is the thermal conductivity.
Okay.
Do they have the K value? They don't. But they have one interesting thing. You see the R value directly? Last column. What they did actually, because the thickness is known already, right? Thickness is known already. So they did the math, L over K. So R value for listed thickness, L over K. Now A value, you got to plug the value, right? Everyone understand how I'm reading this? Okay, so Mitch, you understand how I'm reading it?
Yeah.
This is 0.13 equivalent to 0.111. Everyone understand this, right? And that is what? L by K. So then let me go here. So I'm saying properties. Let me write this thing for you so it could be helpful. So properties. So for plywood, what is the table number? Anyone remember? Is it A5? Sanjal, right? For plywood, for 13 millimeter thickness, right? The R is for plywood is what? R3, right? Is it like L3 over K3A, right? Everybody see that? Everybody got it? So that is the R3 value. Okay, we know that. But from the table, we found R3 double prime, which is L3 over K3. What is the value again? 0.111? 0.110. What is the unit?
Kelvin meter squared per watt.
Everybody see the unit? These are so important. Okay, the way the unit is written, Kelvin meter square per watt. So it's Kelvin meter square per watt. Okay, see if you really understand this. Is that what we read from the table? I think you understand. What did we read from the table? Okay, can you able to find the other two properties as well, the similar way? And I'm going to teach you how to use that value for the R value. Now, even though you don't have a L3 and K3 values directly given, but you have the ratios given, okay? That is even better. You can use that ratio value in that equation to find the value of the R3, right? Everybody got it? Did you understand what I'm saying, right? The ratio is given, it's even better, right? Because all you gotta do is just divide it by A, the area. Area is given, so you should be able to find the value of the R3. All right. I'm hoping you can follow it. So obviously you understand what you're going to do here, right? You're going to go back to the table again after this. So like for plywood and then the plaster board. Let me write it. So plaster board. So plaster board. What is the thickness for plaster board? It is 0.0159, right? So let's see if we have 0.0159. So we have the plastic board, hardboard, building board. So which board you want to take? Gypsum or plaster board, right? We do have this. What is the thickness they have for plaster board? What do we have? We have 13 millimeter. Let's check our thickness. We have 16 millimeter, right? So what are you going to do? Interpolation? Huh? That's the only solution I have. I mean, if you want to use this appendix, if you want to use a different appendix, anybody can Google like the plaster board. Just Google it. I'd like to do this one separately because you can interpolate it
and find. You know interpolation, people. So if you are given with a thickness like 13 millimeter and given with the R by K value for, I mean, you can find the thickness for 16 millimeter, what would be the R by K value, right? So that's the interpolation, but that's a different thing. What's the value, Logan? Yeah. Okay. I'm gonna use 0.2. And you see what Logan was giving here. He was giving from Google a range, okay, and it varies, right? The building material K value property varies. It depends on what kind of cluster board you are using. I mean, I did renovation myself. Even I got like 2 different kind of cluster board from the Lowe's or Home Depot with our box stores, right? And think about it. If you're gonna start to go like real masonry stores or real builders, the place they got it, there could be hundreds, if not thousands, different kind of board. Okay, so that's why they have the range. So it doesn't really matter whenever you're dealing with something, you know the property anyway. So let's assume it's 0.2, right? That's what you said, Logan. So I can use 0.2. What is the unit of the K? Is it watt per meter Kelvin? All right. So now give me the fiberglass as well. Do you have fiberglass? What is the fiberglass K value? 0.03 to 0.04. Let's assume 0.035. How about that? That's reasonable. Somewhere in between. Okay. So let's do one thing. So this one, I keep it as it is. For other two, I'm gonna use the thickness. Okay. Now we have all the properties. Can you guys finish this math? Find the value of the Q. And obviously, don't worry, I'm gonna do the whole thing by myself at some point. Now, this is a little bit challenging problem, and you'll be seeing this kind of problem in exam and in homework both places, where you have to probably find a property value from the table, just like what we did, and you have to do a little bit unconventional, like the R you have to find instead of L over A, you have the L over K is already known. You just have to divide that by A. Does it make sense? How do you understand what I'm saying? This kind of thing you may get exposed, and the other two is straightforward. You have all the K values, you have all the L values, you have all the A values. You can just simply calculate this value. If you understand what you're doing now, you're trying to find the value of R1, R2, R3, R4, R5. Everyone, I want to see you finish the value of the R1, R2, R3, R4, and R5. See if you can able to calculate those 5 values. Okay. If you are done calculating those 5 values, literally you are done with the problems. Okay. Just 2 more steps left. Okay. You understand what I'm saying? Find the values of R1, R2, R3, R4, R5. Once you're done with all 5 values, then you are literally finishing the problem, because 2 more steps left, because you know the value already. You can simply just add them to find the R total. Do you have enough info already to find the R1 to R5? Everybody have enough info, right? Yep. Everybody have everything. I want you to please focus on that and finish it ASAP, so I can at least give you something with the homework, okay? $35.035. 0.035. Is it better now? Is it? Yes. Okay. Hurry up. Find the values. 5 values. 5 values. R1, 2, R5. All of it. Get the calculator. Do some math. Okay? All of you. Get the calculator. Do some math. So your ultimate goal is to find the value of the Q. Okay. Once you have the value of the Q, you are done actually on this problem. And then I don't know, maybe we're not gonna have time for the homework things the way I'm seeing. So whenever you're done with the value of the Q, you are actually done. You can do whatever after that. Okay. Just give me the value of the Q. And I can promise you, if you're done with that, then when you're gonna start solving the homework, at least one problem you can do it without any issue. The second problem, okay? So next class, I want everybody to come here saying, okay, I'm done with the second problem by myself or with my friend as a group, okay? Not like trying to find the solution manual here and there, okay? I want everybody to be confident on that when you come in next class. The exam 2 is gonna come right away before you even blink your eyes, okay? Because exam 2 will be in this chapter and one more chapter that I have to cover. This chapter is so easy, it will probably take just 1 week. And then by week, I'd say week 8, end of week 8, we'll be ready for this second exam. Okay? At the beginning of week 9, you'll be seeing the second exam. Okay, so things are moving really, really fast. We are week 6, day 2. Week 7 is so important. By week 7, I'll try to finish as much as I can for the second exam. And by week 8, we'll be ready actually for the second exam. You have the Q value already?
I got 3.16.
Okay.
The delta T should be in, it doesn't matter, right?
No, delta T here is like, yeah, no, you don't need to convert it to Kelvin. So you see, part A,
I actually got 20.
let me write one by one. So you have this R total, right? Equal R1 plus R2 plus R3, RO plus RI. Okay, so you have this R1 is what? L1 over K1A, L2 over K2A, L3 over K3A, plus 1 over HIA plus 1 over HOA, right? And that's the R total. And then you have this R total. What is the L1 value? We have the L1 value is 0.0159 meter. What is the K1? 0.2 meter. And what is the A? We have the A is 350 meters square. All right. So that's the L over K. K unit is, sorry, 0.2 watt per meter Kelvin. A little congested. So 0.2 watt per meter Kelvin. Okay, plus what is my L2? L2 is 0.0889 meter. What is my K2? 0.035 watt per meter Kelvin. What is my A? 350 meters square. My HI and HO is 1630. Okay, this is choice. All right, 30. So then I have what is my L2 over K2? Oh no, what is my L3 over K3? Is 0.11. Okay, what is my A? Is 350 meters square. Okay, and then we have this 1 over 30 watt per meter square Kelvin. Everybody have that? What I'm writing? I didn't see you guys did that much of writing. Okay, you should have that much of writing what I'm doing here. And 1 over 60 watt per meter square Kelvin, 350 meter square. Logan, what is the value of R total you found? 2.5. What is the unit that you use? What is the unit that you use? Did you use R K over W? Yep, perfect. So then part B is Q equal what? Ti minus To divided by R total. Everybody agree with me with this equation? All right, so then you have this 2.5 Kelvin per watt, and these values are, what is the Ti? 20. What is the outside temperature? Minus 15. So it'd be plus. So total is what? You can say the difference is in Kelvin, degree Celsius, same thing. Kelvin cancel out. What is the value you found, Steve? What is the value? 35 divided by 2.5 is what? What is the value, Mitch? 35 divided by 2.5?
35 divided by 2.5 is 14.
14 point what?
This is 14.
Is this the 14?
Yep.
So log and why you do have a different value?
Because I actually multiplied the area inside by it.
Is that the value everybody got? 14 what? If you did finish the class, though, take a picture of that, finish the class. Okay? Because you're not going to have that. Oh, you're going to have the access to the video lecture. I don't know. Oh, we're going to watch it. Okay. Those are missing technical. You're going to watch it. Probably missing out. Okay. So if you did finish the class, take a picture of that. Finish it. Okay. All right. So please, when you come next week, make sure number 2 of this homework number 4 problem, you should finish it before you come. Okay. Should be able to finish it after this knowledge that you had on today's class. Okay. I'm gonna upload another homework at the beginning of next week. Next week, I'd like to remind you, two homeworks we're gonna finish. 2 homeworks, okay? One homework already started here. So you definitely would like to start with the homework. Don't wait till next week to do 2 homework. Then chances are you won't be learning that much at the last moment.
And then, I'll do correct on all that. I hate using this thing to calculate.
Yep, and don't forget to give me the exam, right? The one question of the exam. Thank you.